this video is about section 5.1 and 5.2 for business calculus, and what it has to do with is the first derivative test. And the information we get from taking the first derivative and setting it equal to 0, we get critical values, and those are places where we might where the derivative is equal to 0 or undefined. So those are places where our curve may be turning around. It has a slope of 0 at one point where it had an absolute max or an absolute min, or where it's undefined, something's harsh like a V shape where it might be going down and coming up. So we need to test those to see what's going on. This gives us information about where our function's increasing, where it's decreasing, and where a relative max or min has occurred. That's why we care about the first derivative test, and that's what it tells us. So the first example, there's only two we're looking at on this video, is on page 330, number 29, and it is a function. This is page 330, number 29, and it says that we have some function f of x is 2x cubed plus 3x squared minus 36x plus 20. And what we need to do is find where this function has any relative max or min. When they talk like that, they mean that's a first derivative type talk. That's the information we get from a first derivative. So take the first derivative, set your function equal to 0, and solve after you take the first derivative. So 3 times 2 is 6x squared plus 6x minus 36. We're going to find where this equals to 0. There's no place it's undefined because there's no denominator for it to divide by 0. So we pull out a 6. We've got x squared plus x minus 6. This will factor pretty easily. X plus 3, x minus 2. Let's see, x squared plus x minus 6. So our critical values is negative 3 and 2. So we must test these right here. So these are our critical values, and what we're going to do is pick a value in each region to decide whether our function itself is increasing or decreasing. So I'm going to plug, these green numbers are right now will be something to the left of 3, maybe negative 4. Something in between negative 3 and 2, how about 0? Something to the right of 2, 3. These are representative of what's happening in these regions. So if I plug in negative 4, I'm going to plug the green numbers into the first derivative. What do I care about? I care about whether this guy is positive or negative. So here is the first derivative, and I'm going to plug in negative 4. I'm going to look right here when I plug it in. I have a 6, which is a positive. And then if I put in negative 4 plus 3, that's a negative 1, so that's a negative. And then if I put in negative 4 minus 2, that's another negative. And a negative times a negative is a positive times a positive means this region is positive. Okay, that gives me information about the function itself. That means the function itself is increasing right there. Okay, how about 0? Well, 6 right here is positive number. When I put in 0, 0 plus 3 is positive. 0 minus 2 is a negative. A positive times a negative is a negative, and that tells me that the function is decreasing during this time. When I plug in 3 into the first derivative here, I have a positive. 3 plus 3 is positive. 3 minus 2 is positive. I get a positive when I plug it in the first derivative. What does that tell me? It tells me that the function itself is increasing during this time. What does this little chart tells me? Well, if they ask me for what regions, for what values of x is this function increasing or decreasing, we could say it's increasing from negative infinity to negative 3 and from 2 to infinity, or union 2 to infinity. Where is this function decreasing? We could say from negative 3 to 2. But what they asked was, where's there a relative max or a relative min? There is a relative max right here because this is going up and coming down. This is where the relative max is. There is a relative max of f of negative 3, which is equal to, I'll figure out in a second, at x is negative 3. There's a relative min with a value of f of 2, and I'll figure that out because this was going down and it's coming up, at x is Now to figure out what the value is, I plug these numbers, -3, the purple number, into the original function. The purple number into the original function. And so that gave me, when I plugged in -3, I got 101. So there is a relative max of 101 when x is -3. And when I plugged in 2, I got -24. There's a relative min of -24 at x is 2. Okay, we have one more example for this video, and it is number 63 on page 331, and it reads like this. The average price in cents per gallon of unleaded gasoline in the U.S. can be approximated by this function on this interval from 10 to 19, where t is the number of years since 2000. And then it says, determine, no, I have got the wrong 63 going on. Hang on. Hold on. Oh, didn't do it. Okay. I was reading the wrong problem. That's what's wrong. 63 is right. 63 is cat function. Cost cat brushes. The cost function to produce Q electric cat brushes. I'm not quite sure what an electric cat brush is, but is given by C of Q is equal to -10 Q squared plus 250 Q. The demand equation is given by P, which is the price, is equal to -Q squared minus 3Q plus 299, where P is the price in dollars. We have to find, we're only going to do parts A through, we're going to do all of this. No, we're going to do A through, no, we're going to do all of it. I'm going to mention something you haven't learned yet, but it'll make sense once we talk about the point of diminishing point. All right, here we go. So this is number 63 on page 331, and I just read it, and it's in front of you. So what we have is this cost function, C of Q. So C of Q, this is number 63, page 331. We have C of Q is equal to -10 Q squared plus 250 Q, where Q is the number of electric cat brushes, C of Q is the cost of producing Q cat brushes, and then we have the price, which is given in terms of Q. So we also have the price, P, which is a function of Q, and it is equal to -Q squared minus 3Q plus 299. So they ask us in part A, there's so many different parts, find and simplify the profit function. So we know profit is equal to the price that you're selling something for times the number that you sell it for. So profit is equal to the price, which is this, -Q squared minus 3Q plus 299 times the number of things you sell, Q. So the profit is equal to -Q to the third minus 3Q squared plus 299 Q. All right, that is part A, find the profit function. So it looks like, did I make a mistake here? Oh, I'm sorry. I did. That is not the profit function. That is just revenue. I'm sorry. Wrong word. This is revenue. The revenue that we bring in is equal to the amount we sell times the price we sell it for. This is the total revenue. And it is a function of Q. Now, profit, which is what I'm meant to be talking about, is equal to how much money you have bringing in, revenue minus the cost. So profit function is equal to revenue minus cost. All right, so the profit is equal to this, negative Q3 minus 3Q squared plus 299Q minus the cost. So minus negative 10Q squared plus 250Q. Alright, so a negative times a negative is a positive. This will be a plus, and this will be a minus when we distribute that negative. So our profit function, which is the answer to part A, is going to equal to negative Q to the third. We have negative 3Q squared plus 10Q squared, which is a 7Q squared. And then we have 299Q minus 250, which is plus 49Q. So part A said, what is the profit function? That is the profit function. Part B says, find the number of brushes that will produce the maximum profit. This is where we take the derivative of profit, find the critical values, and test them to see where a max would occur. So, we do this. I'm going to call this profit P of Q. This is profit function. Where's my other P of Q? Did I put it? This is price. This is the price. Little p. Okay. So, we take his derivative to find the critical value. So, this is negative 3Q squared plus 14Q plus 49. And then we set this equal to 0 and we solve it. This does in fact factor. I'm just going to do it real quickly because I don't want the video to be too long. You can factor this. And I used AC method. I found that, what did I find? My two values, where did I put those? Were 21 and negative 7 were the two values that I rewrote 14 into. Anyway, this will factor and I get that Q is equal to negative 7 over 3. I'm going to immediately reject that because it's a negative amount that I'm trying to produce, which doesn't make any sense. And I got that Q is equal to 7. So when my Q's are so weird looking. Here's my Q. So when I test the 7, put in something lower than 7 and higher than 7. So I put in like 5 and 10. I plugged the 5 and the 10. Let me put those in the green. I put those into the derivative, right? P prime of Q, the 5 and the 10. When I put in the 5, it turned out that I got a positive. That meant that the profit function is increasing right there. And when I put in 10, I got a negative, which means that the profit function is decreasing. So part B said, what did part B say? Find the number of brushes that will produce the maximum profit. The number of brushes that will produce the maximum profit is 7. Okay. Part C said, find the price that produces the maximum profit. Well, here's my price function. If I know the maximum profit happens when I produce 7 electric cat brushes, then the price would be here, negative 7 squared minus 3 times negative 7 plus 299. And when I put 7 into my price function, I get 229. 229. This is the price that I should charge to get the maximum profit. Now, that was part C. Find the maximum profit. Okay, how do you find the maximum profit? Well, you put the number 7 into the profit function. So, when I put 7 into my profit function, right here, the profit function, profit, is going to be maximized when I produce 7. I stick 7 in here. I say negative 7 cubed plus 7 times 7 squared plus 49 times 7. And I find that the maximum profit I can get is $343. So that is part D. Now, part E. I haven't quite taught you this yet, but in the next video you'll hear about it. So I'm going to mention it. Part E says find the point of diminishing returns for the profit function. Okay, the point of diminishing returns has to do with concavity in the second derivative, so this is what's coming. Take the second derivative of your profit. So the second derivative will look like this. Of the profit function would be, the second derivative would be negative 6q plus 14. Find the critical values. Q is equal to negative 14 over negative 6, which is positive, or 7 over 3. Q is equal to 7 over 3. You can test this guy. 7, 3. We're going to pick test values and put them into the second derivative. So this is like 2 1/3, so I could stick in 2 and I could stick in 3 for my test values. I would put 2 into my second derivative, which would give me a positive, which would tell me that my function is concave up, right there. I could put 3 into my second derivative and get a negative 18 plus 14, which would give me negative, and it tells me that my function is concave down. What does that mean? Well, that means that my profit was going from a concave up to a concave down, and there's some point, this inflection point right here is the point of called diminishing returns, where your profit is increasing at a faster rate than it is once it passes this point, 7/3. So the point at which we hit of diminishing returns is between 2 and 3 cat brushes. That's what we would say for part E. And we're going to see second derivative stuff on the next video.